Okay, now let's look at the derivative. If we're given the difference quotient, and the difference quotient you may have seen before in a math class, f of x plus h minus f of x all over h, that measures the average rate of change of y with respect to x over some interval from x to x plus h. So this measures the average rate of change. We heard that before. The average rate of change was the slope of the secant line. If we want to find the average rate of change, but we're only given a single point, we knew that that was the instantaneous rate of change, and that instantaneous rate of change made h go to 0. So we know that if I have that difference quotient, f of x plus h minus f of x all over h, and we want to figure out how do I make it where I'm just looking at what happens at f of x, right? Minus f of x all over h, because I want h to go to 0, that we need to take the limit to find that. So we define the derivative as follows. For y equal f of x,
the derivative of f of x,
which is stated f prime of x, again this is red, f prime of x, the derivative is equal to the following. F prime of x is equal to the limit as h goes to 0 of the difference quotient, f of x plus h minus f of x all over h, if the limit exists. So just a few things. First, the derivative f prime exists for every x in the open interval. If it does, then that means that f is differentiable over that interval. Geometrically, the derivative represents the slope of the tangent line at a given point. It also represents the instantaneous rate of change of a function at a point. And it represents the velocity. Now, another big thing we want to note here, the derivative f prime of x is a function. So the difference from what we're about to do to what we did before in the previous examples is, instead of looking at the point being given, instead of being told that we're going to look from 1 to 1 plus h, we're going to keep everything in x's so that we end up with a function at the end that can be used to find the slope of the tangent line. So the derivative represents the slope of the tangent line, but what we're going to look at is we're going to look at it as a function, the derivative as a function. And we're going to be using this 4-step process to find the derivative. So we're going to define what that 4-step process is as we're looking at example 5. Let's read the directions for example 5 and then find the derivative. So find f prime of x for the following using the 4-step process. And we also want to find f prime of 1 and f prime of 2. We'll do that at the end and we'll discuss what that is. So what's the 4-step process? I didn't write that down anywhere. Well, we're going to do that at the same time as we define it. The first thing for our 4-step process is going to be to find f of x plus h. So step 1, find f of x plus h. Well, f of x plus h is just a function value. It says, hey, instead of writing this x that we have in our function, we're going to write x plus h and we're going to clean it up. So we're going to write 2 times x plus h plus 7, and we're going to clean it up. So distributing my 2, I get 2x plus 2h plus 7. I don't have any like terms, so that's the most that I can do. Then the second thing I want to do is to find f of x plus h minus f of x. So I'm now finding this numerator piece. So step 2, what is f of x plus h minus f of x? Well, I already know what f of x plus h is, right? I already know this portion. I found it above. That is the 2x plus 2h plus 7. So now what I need to do is I need to subtract f of x. So I have to subtract the given function. Well, what's my f of x? My given function is 2x plus 7. So I need to subtract off 2x plus 7. So let's clean this up, combine like terms here. First, I need to distribute my negative. So I have 2x plus 2h plus 7 minus 2x minus 7. Combine like terms. Well, let's see. My 2x's cancel and my 7's cancel. So the only thing left is equal to 2h. So f of x plus h minus f of x is equal to 2h. Step 3 is to figure out what happens when you take step 2 and put it all over h. So we're going to do that right here. What is f of x plus h minus f of x all over h. So we're going to take the answer we just got, which was our 2h, and stick it all over h, and clean it up. Well, notice my h's cancel, so this is just equal to 2. I'm going to scroll up and then scroll back down. So now look, we've gotten this whole entire thing. We already finished that difference quotient. So the last and final step of the 4-step process is to take the limit as h goes to 0. So now what we want to do is say f prime of x is going to equal the limit as h goes to 0 of my f of x plus h minus f of x all over h. Well, again, what is f of x plus h minus f of x all over h? That's what we found in step 3. Well, that was just the number 2. So what's the limit as h goes to 0 of 2? Well, the limit of a constant is the constant, so this is equal to 2. Therefore, f prime of x is equal to 2. So the derivative f prime of x for my particular example, example 5, is equal to 2. Then I was also asked to find f prime of 1 and f prime of 2. So f prime of 1 is just going to be a function value. It says plug in a 1 anywhere there's an x. Well, there's not an x there, it's just a 2. So f prime of 1 is equal to 2. And what about f prime of 2? Well, f prime of 2, again, says plug in a 2 anywhere there's an x, but there's no x there. So in my case, f prime of 2 is also equal to 2. So the derivative, this thing here is a function. It actually is just a horizontal line, but it's a function. F prime of 1 equals 2 represents the slope of the tangent line at x equal 1, and f prime of 2 equal 2 represents the slope of the tangent line at x equal 2. All right, let's do another one of these. Same directions. I'm going to write those directions again. We need to find f prime of x. Using the 4-step process, find f prime of 1 and find f prime of 2. So let's do the 4-step process. Step 1, find f of x plus h. So f of x plus h is going to equal, again, everywhere there's an x, instead of writing x, I'm going to write x plus h. So x plus h squared minus 4 times x plus h. So x plus h squared, I'm going to write that twice and FOIL it. And then I'm going to go ahead and distribute my negative 4 inside that parentheses. So I have negative 4x minus 4h. If I FOIL out x plus h times x plus h, I get x squared plus xh plus another xh plus h squared. Still minus 4x minus 4h. Combine like terms, and I end up with x squared plus 2xh plus h squared minus 4x minus 4h. Step 2 says take f of x plus h and subtract the function. So my f of x plus h is this thing above, which is your x squared plus 2xh minus h squared minus 4x minus 4h. And now I need to subtract my function. Well, the function was the given, and that given was my x squared minus 4x. So that's going to equal, if I distribute the negative,
Negative x squared plus 4x.
what's going to cancel? Well, my x squareds cancel, and my 4x's cancel. So I'm left with 2xh minus h squared minus 4h. Step 3, put that all over h. So we have our 2xh minus h squared minus 4h all over h. Well, again, notice everything's got an h. So I can cancel out the h's. From here, I'm just left with a 2x. From here, this is just an h. This is a 4, and this is a 1. Therefore, and we'll write it here, f of x plus h minus f of x all over h is going to equal 2x minus h minus 4. And we don't need to put that all over 1. The last and final step, step 4, is to take the limit as h goes to 0 of my f of x plus h minus f of x all over h. So in this case, I'm looking at the limit as h goes to 0 of 2x minus h minus 4. And this is just direct substitution. So the limit as h goes to 0 of 2x, x is not the variable in question. The variable in question is h. Since x is not an h, it is treated as a constant. So the limit as h goes to 0 of 2x, well, the limit of a constant is the constant. So the only time you plug in a 0 is in place of your h's. Everything else remains the same. So then we say minus 0 minus 4. If I clean that up, I get 2x minus 4. Therefore, f prime of x is equal to 2x minus 4. Well, now we need to define f prime of 1 and f prime of 2. So f prime of 1 is going to be 2 times 1 minus 4, or negative 2. What does that mean? That means that the slope of the tangent line at 1 is negative 2. And then I also need to define f prime of 2. So plug in a 2 in place of your x. So we have 2 times 2 minus 4. So f prime of 2 here is equal to 0. What does that mean? The slope of the tangent line for that particular example is equal to 0. Let's do one more of these, and then we're going to look at things being non-differentiable. 4-step process again. Step 1, f of x plus h. So we have 2 times x plus h minus x plus h squared. So if I distribute my 2, I have 2x plus 2h minus, I'm going to write this twice in FOIL. So 2x plus 2h minus x squared minus, plus xh plus xh plus h squared. Combine those like terms and distribute the negative here. Distribute the minus sign that we always had in front of it. Distribute the negative. And we end up with 2x plus 2h minus x squared minus 2xh minus h squared. Step 2, f of x plus h minus f of x. So we take what's written above, 2x plus 2h minus x squared minus 2xh minus h squared, and we subtract off the given function. The given function was my 2x minus x squared. Distribute my negative there. I end up with negative 2x plus x squared. Combine like terms. Let's see what cancels. Well, my 2x's will cancel, and my x squareds would cancel. So I'm just going to be left with a 2h minus 2xh minus h squared. Now we want to put this all over h. So my 2h minus 2xh minus h squared. And again, notice that everything's got an h in it, so my h's will cancel. So from here, I'll be left with a 2, a 2x, an h, and a 1. So this is going to equal 2 minus 2x minus h. Finally, step 4, f prime of x is going to equal the limit as h goes to 0 of my 2 minus 2x minus h. So the limit as h goes to 0 of 2 is 2, of 2x is 2x, of h, plug in a 0. So you end up with f prime of x is equal to 2 minus 2x. So now what we want to do is find f prime of 1, and we end up with 0, which means the slope of the tangent line at 1 is 0. Now let's find f prime of 2. So f prime of 2 is 2 minus 2 times 2, which is 2 minus 4, or negative 2, which means the slope of the tangent line at 2 is equal to negative 2.